generate the data sets. And then, okay, and then we can look at the coefficient. And here you will see that by reducing the number of samples, we are not able to recover perfectly the coefficients. So then this is like, there should be one thing that is an assumption that somehow you need to have enough samples to be able to recover like the true data. So this is only one of the assumptions. And basically there's three assumptions that go with this to say like, how can I recover the perfect model? So enough data is actually infinity. Okay, so that's a bit hard, but the theory tells you that if you have an unlimited number of samples, then you will be, and that your model is well defined. So basically, the model just can fit the data generative process. Then, and that you are minimizing what we call a strictly proper scoring rules. So for instance, the log loss is one of them. If you have those three conditions, then you recover perfectly basically the coefficient of the true model. And in machine learning, what happens is that you never have those three. Okay, so either you are on limited sample size, so then you will have difficulties to recover that. Either you never observe like the data generative process. I mean, you have only what you obtain from the data that you have at hand is only a proxy of the true problems. Otherwise, we could just like understand the world in some way. So usually, you just have like it's not as flexible. I mean, you don't have enough feature basically to recover that, so you will make some mistakes. And regarding the strictly proper scoring rules, usually this you can manage. Like a lot of the estimators, so if you take decision trees, that minimize the entropy. Entropy is a strictly proper scoring rules. Log loss is one. So usually this, the machine learning model that you have try to minimize such rules. I mean such loss. Okay. So and now, so when you do that, what will be the effect now is on the predictions, okay? Seeing that we don't recover properly like all the coefficients, we will have as well an effect on when we try to predict. And the direct effect is on the probability. So Scikit-learn provide you this predict proba, which will tell you, which I break the microphone as well. So it will provide like some numbers which we call probabilities, but one important thing here that you to understand is that they are not the true probabilities. They are an estimation of the probabilities, okay? Because the real probability is the one, I mean, that's the one of the data set, that's the prevalence, like how likely it was. And when we minimize our params, we try to estimate at best, basically, those probabilities. And the log loss is, you can basically decompose the log loss into several terms, the calibration terms, and some other terms afterwards that you will explain inside the second notebooks. But so what you try to do is to minimize that, and if you minimize like this to 0, then you recover the true probabilities. So if I get the probabilities and, for instance, compare, which is the second part here, if I look at the probability of my model compared to the true probability on my generative params, I will see that I have a little shift because here, because I didn't have infinite sample size, and that I didn't recover like the model, then this has an impact on the probabilities. So I don't have like the true probabilities. If you would put like 1 million samples, then you will reduce basically the calibration errors in this case, and you will come back to having like two distributions which are much closer. Okay, so there is these things on why calibration is important is because somehow if you have the true probabilities, usually what you do is you will go from those probabilities into a decisions. So if we give you like a number which is meaningful to you in terms of probabilities, then your decision will be better. And if we look then the proportion, for instance, so in this case, we saw that we have a small differences. So if we look at the proportions regarding the distribution, let's say, and like the average distribution, we'll see that we have a little shift, but that we are close. Okay, so because our model didn't recover perfectly, but still is not bad. And usually, to assess the quality of these estimates, or like to know, what we look at is the calibration of the classifier. And this is something that we'll look at in my data sets. What is the proportion of, let's say for a given bin, how many examples are positive compared to what is the probability that I say for that proportion. Okay, so, and then you will do that for all the elements. And here, because we have an imbalance case, events are very rare, so we don't have a lot of data for the upper part because everything will be with low probability because, I mean, by design, I have low probabilities, okay? So it means that everything will be concentrated on that side. And if I zoom in, which is this plot here, what I absolutely want is to be on the diagonal. So like this, it means that the estimate is very close to the true probability. In case that you go off basically this diagonal, it means that your classifier will be either overconfident or underconfident. So for instance, it will tell you, I have a high chance that this is a positive class, while inside the true data, this is not the case. Okay, so this is like what when you want to estimate, like if my probability are good, usually you make this, this curve and you look at how far you are from the diagonal. And in the notebook here, that's what you have a lot, basically inside. You have a lot of details regarding that part in the over notebooks, which is a tutorial that we gave like 2 years ago with Olivia. So here, what the important part is to say, okay, we make a models where we didn't have like infinite sample, but we are able to recover good things because at the end, we have kind of like not bad probability estimates, okay? So we should be able to take decisions. But is where, like in terms of scientific literature and understanding the problem, where things went sideways. So why? So usually what you are interested in is not to have the probability, but to take a decision. So for instance, I'm inside the clinical trials. I want to know whether or not this person or clinical trials or let's say I have patients with a concern or concerns, and then you want to take a decision through, I have this probability and I want to say, okay, this is likely that this person has a concern. So then I want to take a decision and do something about it. So it means that you transform this probability into a hard decision. So you kind of threshold the probability estimate. And in scikit-learn, this is where you have this predict. And this predict, it just, the rules is, I cut at 50%, okay, because that's the standard way. If I'm inside the balance cases, it's like if I have more than half of the odds to be true, then this is true. Otherwise, it's the overclasses. So by doing these results, and I compare, for instance, with what predict from scikit-learn will give you, then you will get exactly, I mean, that's exactly what's happening. So when you call model.predict scikit-learn, you can think that it does the probability cut as 0.5, okay? When you have a probabilistic classifier, which is most of the case, okay? The only one that doesn't do that is SVM, but don't use SVM, okay? That's, okay, and why does people found that this is kind of an issue without going, like, understanding what really is happening is usually from that predictions, you go to metrics, okay? And the first metric that you will build metrics basically based on this confusion matrix. So the confusion matrix will tell you how many true positive, true negative, false positive, false negative you will have. And then all metrics around that are just like, how do I combine different square basically from that metric, from that matrix, and then it will give you a number which you try to maximize. Okay, so like this, you say I'm better. And what you expect inside this matrix here is to have this diagonal, okay? So the upper left and the bottom right to have most of the sample there, because it means that I didn't do any mistake. I was able to predict the positive, and I was able to predict the negative. And one of the things that people will not like my classifier here, when I use model.predict, if I don't know that I have a relation between the two, is that it's very bad at classifying, for instance, like my positive here. So people go from the pretty symbol, this is broken, okay? Because I mean, like, I don't manage to get a good output. So from there, as I say, you can compute metrics, and for instance, in this case, you could compute the precision and recall. We'll put on the side the F1 score is just an average of the two, but again, you should not use this metric. And here we see that we have a score of precision and recall at 0. Okay, so you say this is a params. I would like to be able to have a much better precisions and recall as well for the positive case. So what do people are doing usually? They will say, okay, so the intuition there is my classifier was able to learn the negative classes, but was not able to learn these positive classes. So probably what I can do is just remove samples or do like play with the distribution of the original data and sample the data. So either create new sample from the positive class or remove sample from the negative class, okay, which is kind of the same. And this will have an impact on my confusion matrix because that changed my model. This is not the same param, but that will improve. I try to improve basically the number based on this resampling approach, and then you can have like a lot of methods for that. So here I have an example where we will undersample the negative class. Okay, so it means that we'll try to rebalance to have, so here not as much, but at least to have like much closer number between the negative and the positive. And there's a library for that, which is called imbalance learn, that nowadays maybe you should not use. And we will see that when you feed the model and then you compute the decisions of this model, then you have the impression that it's working very well, I mean, much better, because you were able to move from some of the samples that were false negative into the true positive. So you say, now I'm able to detect some of those. Of course, it comes with moving some true negative into the other side. Okay, so now you make mistake as well on the negative. Okay, so this is not like perfect, but somehow you are moving things around. And so it means that here we reduce some of the score of the 0 regarding the precision and recall, but we somehow moved some numbers and we are not at 0 anymore. I don't know if this is a good number, but at least we are not anymore at the 0 where we had the impression that it didn't work. So now I have an exercise for you. It's like, okay, is what usually people will do in different manners, but what I want you to realize here is, can you retake the code that computed the calibration here and check the calibrations of these undersampling models? Okay, so I want you like just do that and try to understand like what was the effect of this resampling on the calibrations, which means that the effect on the estimation of the probability. Okay, and see what exactly did we do here. Okay, so I can let you 5 minutes to copy paste code and get intuitions. And again, if you have any questions, just. So what you have to do, so here we created a models. We were able to see the confusion matrix, which are the R decisions. And what I want you to do is to retake this analysis here, which is a calibration display, and instead to here inject basically your undersample models and observe how this calibration curve changed for this model which was undersampled. Okay?
Is there any question?
Talking about the imbalance predictions as well, we could have changed maybe the The threshold, I mean, applied when predicting the
It's what you should do. It's the next. So
okay.
we are getting to this. But I present you the problem such that you have to think like that's the right things to do.
Any question?
In the same notebook, but somehow I cannot select the IPy kernel. So
Okay.
I cannot run anything. Yeah.
So that Pyodide might be the internet connection is bad, and then because Pyodide launch the notebook, get the kernel, like download all the packages. If the Wi-Fi is very slow, then you don't have any answer. And so can you try to run like maybe Pixie in this case and see how the download is going? That might be easier. So if you do Pixie run Jupyter Lab, then at least you will know about the downloading. Yeah, that's the bad part about Jupyter Lite. You still need internet. So yeah, I'll check.
No, but I want to try to so I'm using this wall.
Yeah. Which person? We need to see. Yeah, you have the error coming from select my engage. But can you just try like to get with Pixie? I mean, for sure that should work. And I missed, there's another plot that you can do. That's the true coefficient of the model compared to the previous one. So basically it was this plot here. If you want to quickly, you can quickly look at it. Okay. So here, so let me first look at the coefficients, and like this we can see what happened with these models. Like, did we recover or not, like the true coefficient or close to what we saw before, or like what was the effect there? And then we look at the calibration curve. Okay, so like this is two ways to debug what's happening. So first one, if I look at the coefficients, we see that we recover very well the feature, but then we have something bad for the intercept. So by definition, it means that here we were not able to recover the true data generative process, while without any sampling, we were able to do that. So that's an interesting thing, really. Like that's not the good models, okay? We have another models. And if we think about what the intercept does with linear models, that's kind of like easy, because a linear model is a line that you are moving in terms of decisions, and the intercept is just like moving the decisions like parallel, basically. So if I have like the sigmoid, basically, you are just moving basically the sigmoid. So somehow we are shifting like the decisions. So undersampling had these impacts, which come back to what you said. This, I can do that with the threshold. Okay, so that's, so here I corrupted my model with this, with the intercept. And what the impacts is, then we get a classifier which is overconfident, okay? Because, so the line doesn't follow anymore this diagonal, and if I read what's happening here is that the estimate of the probability are much higher. So, for instance, I will say, you have 90% to have a cancer, or like I have 70% to have a cancer here, while before, if I look at the true data, only 10% of the populations were positive in this case. So we just, what we did here, we artificially push our classifier to take a decision to be overconfident inside the decision that he's taking. But somehow this is exactly what we pushed here, or what we wanted to in terms of decision. So we broke the probability estimates to accommodate the final decisions, okay? While this is actually not what you should be doing, what you should have is like best of the two worlds, is I have the true probability, and then my decision should be taken after like thresholding and moving this threshold, and then I will have the best of the two worlds. Okay, I will have my decision that I want and the true probability of the models. So I will pass this exercise and I will let you do the next one. So here, what was the exercise about is to say, okay, my undersampling model here is not well calibrated. In scikit-learn, you have methods actually to recalibrate the model. So to make that the estimated probabilities follow actually like the estimation of a validation set. And this meta-estimator is called calibrated classifier CV. So what you do is just pass the undersampling models, and inside it will do cross-fitting to on the validation set to see what correction you need to apply such that I get the right probability. So if I do that, I take my models, I fit it, and then now I forgot to import this. I execute it. So I get my undersample model within a calibrated classifier, and I redo exactly the same analysis with the calibrations. Okay, my classifier is now well calibrated because that's the purpose of the calibrated classifier CV. And if I look at the confusion matrix, I'm back to square one, okay, to my original logistic regressions. Because, yeah, I just put it back. If I take my threshold 0.5, I'm back to my original logistic regressions. Yeah. Okay, so I will reset the questions. So the question is, in terms of undersampling, there's overfitting in scikit-learn that allow you to correct basically the weight of the classes, which is called class weights. It has exactly the same effects than sampling. It's just that here, what you do is you remove samples, so such that you don't see them in the loss. Class weight will just diminish the weight of a specific, or of all the sample of a class, which in terms of mathematics is exactly the same things. So you discard it, it's not exactly the same effect because with the resampling, you might go much faster because you see less samples. But in terms of mathematics, that's going to be equivalent. Yeah, so you have an impact on the uncertainty if you're interested in what is. Yeah. The second notebook. So yeah, you can. So what you can do. So in this case, I wouldn't do that, but is what we'll see afterwards. If you have too many negative, for instance, and that you spend your time on learning on negative, and you have millions of them, and you don't have problems with uncertainty, you can use the random sampling to reduce the number of data that you want to learn. So this is much faster, but then you have this bias. And then you can use actually your closed-form solutions to recalibrate instead of using the calibrated classifier, because you know how to move the intercept. But that's exactly the notebook number 2. Yeah. Yeah, but so I wouldn't agree on this because here you just take a random undersampling. The fact that this moved is just that you are on like a bootstrap of the data that you have at start. So this is just what you can only deduce here is just random noise. So I would say that if you repeat the experiment, there's maybe one model that actually will not pick up 0 and 0 at some point. But it's just a sampling, and it's just like on the noise side because you just remove samples from there, and you didn't really give a chance. Because at the end, the learning theory is if you minimize the log loss, you will recover the best models, which have like the true coefficients. Okay, so if you go back to that specific plots. But again, like even on the final samples, I recover very well the coefficients. Yeah, but you still have like 10,000 samples. I mean, like, so I'm pretty sure that you are fine. The only difference is that this one is not perfectly calibrated. So if you recalibrate that one, then you will not end up with zeros, and that's the only thing that you change. So because we have this little error inside the recalibrations, but it's not about the sampling. The same, like the sampling, if moreover you do is try to do smart sampling, then it's just that you change your learning distributions. So you are not even like this having the same problems. Okay. So yeah, we recover a calibrated classifier. We see again the same issues. And then if we compute the probability that we have here, then yeah, we have more or less like the same issues with the precision and recall. So here, because we have like a couple here, then like that's improving with the precision, but this is still an issue there. So the important part here is to understand that if we wrap up, is that you have different type of metric that you can measure and different type of prediction that you can provide. So if I call predict proba, I get probability estimates. So this is not the true probability, this is an estimation. So it's as good as what if I try to recover my models. Predict is actually a thresholding of this. And then what we have on the top of those is usually metrics that are specific to quantify if those are good. And you have three family of metrics. Precision, recall, and all of those are defined from the confusion matrix, which are defined on the metrics which are threshold, like the decision which are thresholded from the probabilities. If we want to evaluate the probabilities, then we need to use proper scoring rules, which is prior score or log loss. And then there's a metric in the middle, in between, which doesn't really care about the probabilities, but they care about, like, did I put the sample in the right order? Like when I put like the probability or the sample in the right order, and is all what is about ROC AUC or precision, average precisions, okay? Because you just like check the orders. But in this regard, so it just checks the power of discrimination of a classifier, but it doesn't care about like are the probability are well calibrated, okay? So this is so you have those three families, and depending on what you are trying to measure, basically, you will use these different measurement. But what you have to understand is what do you inject as prediction? How do you find those precisions there? Okay, and so the final, before to go, because we are almost at half time. So here is to come back to what we should be doing. And basically that come back to your reflection here is that if I have a well-calibrated classifier, the thing that I could move is this threshold. Up to 2 versions of scikit-learn, you couldn't do anything. I mean, you had to manage yourself. So it's like you needed to take the predict proba and do a meta learner and doing whatsoever. Since we included 2 classifiers, which does this job for you. One is called fixed threshold classifier. So you will provide your classifier and you will say, actually, I don't want to cut at 0.5, but I want to cut at this other
Don't drop that thing. Oh, hello. Yes. But I'm very loud, though. I don't know if people want that. I put this to my belt so it doesn't fall off. I may run around. You know, I never sit still, right? That's all right. It's fine. Yeah. Maybe you can sit like, just, yeah, don't sit in the middle. It's like in the plane, right? So yeah. I always wish people, like, if they know that they're going to, like, use the bathroom quite often, they just sit in the aisle instead of, like, in the middle. Because I'm the person who, like, sleep through the whole flight, so I like sitting in the middle so nobody bothers me. Yeah. Yeah, exactly. I was like, I'm sleeping. Don't wake me up, Yeah, I would even skip food. Like, I don't like the plain food anyway. So I was like, I'm just sleeping. Okay, let me zoom in so you can all see. Shout if you can't see or not big enough. Hello? Okay, so I hope a lot of you already see my instructions on Discord. If not, it's fine, don't worry. Go to this GitHub repo. So this is this is how GitHub works, right? Put in my name and then put in the name of this repo. Go here, get it, of course, and then try to also set up the environment as well. I think, yeah, there's a PyProject.toml, so probably you can use UV to get everything. And then the next thing that is takes some time to download would be the LLM that you want to try it out. Since this is just an exercise and we are just learning how things work, we probably just run it locally, right? So don't do anything crazy like have your the top-notch state-of-the-art model. Probably your computer won't be able to handle it. I would suggest getting either GPT-2 from Hugging Face. That's quite a small enough model. It's not very good, but doesn't matter. We're just having fun today. Or QN is also a good one. That one is by Alibaba. It's also quite small. Yeah, so get something like that, or DeepSeek if you want. But I don't know I think DeepSeek also kind of, their reasoning may be a little bit different, but I think they also have the Open AI API, which I think will work with the tools we're using today. So get those, and then we'll start from there. So while we are waiting, if you haven't downloaded any of those, or you are missing I haven't get the model yet, then it's very easy. If you open part 1, I think run a little bit of the script at the beginning. I think it will start downloading already from Hugging Face. So, yep. Let's see. So far, so good. Anyone have questions setting up? Anybody has not set up and is not ready to go? Okay. Since there's almost half, I would say that, do that. For those of you who are already, you're like, oh, I'm ready to go, what should I do? Go to the first, the part 1 folder. There are already some instructions there. What you need to do, since what I like doing during the tutorial is instead of hearing me yapping and then seeing me do it, and then, or if I give you a script, you just run it, I think that you would learn nothing. So, so I prefer that you actually have something to do, that you have to really use your brain to do something. So for this workshop, there are 3 parts. So each part, there will be a script that is not complete. So it doesn't work. It may, it may hit something that I have. For example, this function doesn't exist. I've removed it. Then it would have some error if you try to run it. So the first part of this exercise, which is the first task when you're ready to go, is to refresh your memory about Transformer, which is by Hugging Face. I hope this crowd are more familiar with Hugging Face than when I do it in a other conference where like people are not data scientists. They're like, what is Hugging Face? So do this. Maybe for you it's like, not that difficult because, you are maybe more or less know how Hugging Face work. What are we doing here? But yeah, try to fill in the gap. There are some to do that is written in the comment, highlighting what you should do already. So another thing is that, if you can remember all the functions and everything of Hugging Face by heart, yeah, you don't need it. But most of us, probably even if you use Hugging Face quite frequently, you still need to have a documentation. So make sure you have it handy. Maybe open it on another tab, and then keep checking like what should be the input and stuff. Or if your IDE like PyCharm, the one that I'm using, that like it will give you the hints and stuff, which is brilliant. So yeah, I will let you to do your own thing. So either set up or start working on it. Again, like this tutorial, I would always say that like in case I got sick and I don't appear, then people can still do it because everything is written, everything is kind of self-driving, like kind of self-paced. So yeah. So I'll stop yapping and let you get on to it. If you have any questions, put your hands up. I will come to you and have a look, and then or anything you don't quite understand, maybe like you are not that familiar with Hugging Face, like what is this doing? Then also it's fine. You can ask questions. So yeah, cool. Let's do it. I'll go back to the front page so you will see the Oh, sorry. I can't use my phone then. Or I can switch it off, right? Sorry, could you repeat?
Yeah, I mean, this gives me an assumption of knowing a lot of stuff.
Right, it's fine. I can come and explain to you.
I wonder whether it's a good idea just to walk through exercise 1 or something.
Well, I can give a brief introduction. Maybe let me check where everybody is, and then if more people are interested. So who is still setting it up and need more time? Okay, right. How about that? Like, I will do a walkthrough, and like, if you want to know, you can follow along, and then if not, then keep doing what you're doing. Okay. So if you are setting up, it's fine. You can still multitask and look at me. That's fine. Okay. Cool. Yes. But anyway, thank you for letting me know. So yeah, because I don't know where people's level are, so. With that, we are doing this. Okay, explanation. So the part 1, so what we are doing is to, do a small task using Transformer. So for those of you who may not know what Transformer is, it's actually a library, a tool provided by Hugging Face. Hugging Face is kind of, if you're not familiar with it, it's kind of like GitHub, but for mostly focused for data science. So what you can do is that not just sharing your code, your project, but you can also share data. You can also share the model that you have trained. So, so that's why Hugging Face is quite good. If you are a researcher who are working on open source AI or LLM or anything like that, or deep learning. So, yeah, so what we are trying to do here is to, of course, finish the script, but what the script is doing is that it will get a pre-trained model. So in the default is GPT-2. And then after that, we will get a data set from Hugging Face. It's provided by OpenAI, so this is the name of it. So again, this is the default. You may, when you're more familiar with what we're doing, you can change it around and play around. But this is, I will just tell you the default, and then you can, of course, change anything. After that, we will have to tokenize it, because for LLM, what happens is that how machine can process natural language is, because machine deal with numbers, right? Like, we know computer is basically 0 and 1, and then it's very good at doing mathematical things. So how does it understand natural language is that we tokenize it. There are different ways of tokenize it if you have done some NLP kind of work before. However, I'm not going deep down into it because, again,